Hi, Daniel.
Welcome. 8.2 L'Hopital.
Shalom, Daniel.
So indeterminate form is just when you have 0 over 0. So this happens if you have two functions as you're approaching A and they both go to 0 at A. You have an indeterminate. What the heck? So this is meaningless. So if we use L'Hopital, aka the limit as you approach A is just going to be the derivative of each over each other. As long as the derivative is on the bottom doesn't go to 0. So we can do example 1. So if I apply L'Hopital, this is hard to write. I have the limit as x approaches 0. Let's see, the derivative of sine x is just cosine x. Derivative of 2x is just over 2. So as I approach 0, this is going to be equal to cosine of 0 over 2. Well, that's just equal to 1 over 2. Just a half.
Use L'Hopital's rule even when it is an indeterminate form? Like, can you apply the same principle? Even if you don't need to?
Only like you only can use L'Hopital if f of a and g of a are both 0.
So if it's an indeterminate form?
Only if you're in indeterminate form.
Okay. Otherwise,
that's what it works.
Like it just won't give you the right answer.
Otherwise,
perhaps.
Uh-oh.
Alright, so let's do this. So the second one, if I apply L'Hopital, I'll have the limit as x approaches 3. This is derivative of the top is 1, derivative of the bottom is 2x. So that's just 1 over 6. So 1/6. Ugh. This is hard to write. Alright, sometimes after differentiation, the new numerator and denominator both equal 0 at x of a. In these cases, we apply a stronger form of L'Hopital. So what do you think the difference is between the top and the bottom? The first form and the stronger form?
I'm not sure. It's the same formula.
Literally, it's the same formula. It's just the difference is, if there's still an indeterminate, do
just,
it again.
Just do it again.
Do it again. All
Wait,
right.
do you want me to take notes on the thing and then you can like write on the board, and I can just like write down on the thing what you're writing on the board? Like,
It's not gonna be easier writing on the board. Well, it's
Up to
fine.
you. Just give me
It's fine. It's fine. So if we apply L'Hopital here, okay, so apply the stronger form to find the limit. So as we approach 1/2, I have 1 over sine theta over 1 plus cosine of 2 theta. So if I apply L'Hopital, the limit of theta as it approaches pi over 2. So this is, let's see, derivative of 1 minus sine theta is just going to be minus cosine theta over the derivative of 1 plus cosine double angle is just going to be minus 2 sine 2 theta.
Is it possible to take Calc BC without having to take an AB? Since a lot of it's like repeating stuff.
Well, you would have to like self-study. It's how Henry did it. So, he literally spent the whole 4th quarter self-studying. Yep. And like if you have proof, like Kasif is very like understanding. Like if you know your stuff, we have no issues putting you in a class that fits you. But you have to like prove it.
You have to like take a test, right?
Yep. So it is possible to come to BC, but you see how like fast we go over the stuff? I expect you to remember stuff from last year.
Yep.
I expect you to.
Placement tests are hard. I don't like placement.
They are hard. So all right, let's keep going. So what happens if I plug in pi over 2 for theta here?
You probably get indeterminate.
Wow. Nice.
Well, what do you get? The top goes to?
0.
The bottom goes to?
0.
Right. Because sine of 2 theta is just sine of pi. Sine of pi is 0.
Yeah.
So you do get indeterminate. So let's apply L'Hopital again.
It's like, no, you just get the answer. This is not, you don't have to use stronger form here.
I'm going through it to make sure like you guys are processing, not just like bobbleheading. Derivative negative cosine theta is
Sine theta.
Okay. And derivative of negative 2 sine 2 theta is negative 4 cosine 2 theta. Now let's try plugging it in.
Wait,
Can you read that?
No, I can read it fine. I'm just confused as to how you got that.
The chain rule.
Yep. Derivative of sine is cosine. Derivative of 2 theta is 2.
Oh, and then times the negative.
Yeah, times the negative 2 that's in front.
I haven't heard
Then if I derive this again, you know, it would be a positive 8 sine theta.
Yeah, I just haven't done.
It's been a while. All right, so let me plug in pi over 2. Sine of pi over 2 is 1 over
-4.
negative 4 times cosine 2 theta. Cosine 2 times theta is cosine of pi. Pi is -1, so that's equal to 1/4. It's positive. Trick play. Gotta, you know, write it out so you don't miss that negative.
I did miss that negative.
You did. Got him. Got him. All right. Let's try the next one. Let's see how far we can get today. That'd be great.
Okay.
Remember how that one day we got through almost
Yeah, we killed it yesterday. Or
2 days ago?
2 days ago. Tuesday.
All right. So limit of,
That's awesome.
as we approach,
Wednesday.
what? Limit as x approaches 2 of x squared minus 4x plus 4 over x cubed minus 12x plus 6. Okay. Let's apply L'Hopital.
Okay. So then 2x plus, or 2x minus 4 over 3x squared minus.
So if I apply 2 here, the top goes to 0, bottom goes to 0.
And it probably does that again.
Yeah.
So now we have to do it again. 2, 4, 6. So then 1 over 3x.
6x.
And that's just 1 over 6. Yay. Wrapping.
Sweet. Okay, cool. So we also can use it for one-sided limits. Because at x equals 0, sine of x, sine of 0 is 0. X squared, well 0 squared is 0, so this is an indeterminate form. But if I approach it from the positive side, like, yeah, I can evaluate this limit. Okay.
So again, you have to do like the stronger formula, right?
Well, we'll see. So going from the positive side, I have the limit as x approaches 0 from the positive side.
So it's a negative sine
Cosine
negative.
x
Regular cosine over 2x.
over 2x.
twice. It's negative sine over 2.
Well, let's plug in x equals 0.
Wait, still over 0. Wait, that's not indeterminate.
It's not indeterminate. Trick play.
So what do you have to do? So it's just like no solutions?
Does not exist. Or infinity. That's the answer. 1 over 0 is not indeterminate.
That definitely is a trick play.
Yeah.
That means he's definitely gonna have it on the quiz.
I don't like Danny. Something I said I don't like Danny.
Yeah,
That
that's
is
exactly
definitely-
what. Yeah. Haha, Daniel.
Ooh,
All right.
Daniel, dude.
So this is for indeterminate forms. Keep in mind. All right, let's do this. Limit of tangent of x over x. Limit as x approaches 0. So let's apply L'Hopital.
What's the tangent of 0?
0.
0.
You're right.
But we need to. Right, so this is definitely indeterminate, right? Tangent 0, 0 over x. Well, it's 0, 0 over 0. What's the
like-
derivative of tangent?
Secant
Secant squared.
Secant
Oh,
squared.
no.
No, wait.
Secant
Oh, it is
squared.
Sweet. Wait, what's secant tangent then?
Huh?
What's secant tangent?
It's definitely something.
I think so.
I think that's the derivative of secant.
Is it secant squared? Oh yeah, you're right. Yeah, that's right. You're genius, bro.
Occasionally.
So if I put in x equals
Well,
0.
it's not going to be indeterminate form.
Right, because the bottom is now 1. But
And the top
if
would be
I.
0.
Is it?
No, it wouldn't.
Secant of 0 is equal to what?
1 over cosine.
So what's cosine 0?
1. It's
Okay,
1.
so 1 over
it's
1 is 1. So 1 over 1?
It's 1. I
Yeah.
said a lot of 1s there.
It's just 1.
Oh, okay. Are we doing this second one? Ooh. I've been ahead.
No, I fixed it. You were going to do the regular
Alright, here are other indeterminate forms. L'Hopital can also be applied to quotients that lead to indeterminate forms of infinity over infinity. So not just 0 over 0, but any indeterminate form. Indeterminate 0 over 0, infinity over infinity, infinity times 0, infinity minus infinity. We can sometimes handle the indeterminate forms, infinity times 0 and infinity minus infinity, by using algebra to get 0 over 0 or infinity over infinity instead. Remember, these forms are not numbers, but they're descriptions of function behavior. This is why when my pre-cal students ask me about infinity, I get really weird about it, because I don't know how to describe it to them. I start describing like...
That becomes like philosophy.
Yeah, it gets real trippy.
What is infinity?
All right. So is that clear what we just went over? The fact that ideally we want infinity over infinity or 0 over 0. Do you want me to shut the door?
Yeah.
Actually, we shut the door, Bradley.
Here's the real question.
So if you can...
What is infinity plus 1?
Infinity. Language. I'll start calling you... Never mind.
Start calling
I was going to call you a kid's name in my class, but Daniel does not need to hear this.
Yeah, Daniel. Yeah, you have yourself on record.
Yeah. Okay. Oh, I have a subscriber. Did I tell you that on my YouTube channel?
Who is Miss K?
No.
It's some random student.
It is one of my students.
Sal Khan.
But other people sometimes watch these videos.
Really?
That aren't us. Yeah, so sometimes, just FYI.
Just to understand, how to do, a certain type of math.
Or they're like, oh, what's Calc BC learning?
It's the notorious O.
Okay. Identify the indeterminate form.
No, you don't get a high five.
Identify the indeterminate form and evaluate the limit using L'Hopital's rule. So as we go to pi over 2, what's the indeterminate form here? So what is 1 plus secant of pi over 2?
What's secant of pi over 2?
What's secant of pi over 2?
It's cosine of 1 over
Well, secant is 1 over
one.
cosine. What's cosine of pi over 2?
Root 2. Wait, no.
What's cosine of pi over 2?
Oh, it's 0.
0. So what's 1 over 0?
Indeterminate form. Or no, just
Does not exist.
Yeah, exactly.
Well, as we approach. So as we're approaching 0 on the bottom, as we get smaller and smaller denominators,
Oh.
it's saying what's the limit as x approaches pi over 2. So as we go from 0 to pi over 2, as we get closer, secant is approaching, right.
Oh.
And then tangent of pi over 2, what's that?
Could be 0. No. Infinity?
No. Oh, yeah.
Cosine over cosine, sine is 1, cosine 0. Except it's not 1 over 0. We're approaching 1 over 0. So we're approaching, as we get smaller and smaller on the bottom, as we get closer to pi over 2, the bottom of the fraction gets smaller and smaller, and then the whole thing is growing. So if you remember, the graph of tangent looks like this, and this is at pi over 2, it goes to infinity. The graph of secant looks like this. Let's see.
Oh, yeah.
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 So at pi over 2, we're approaching infinity. Cool. So this is the infinity over infinity indeterminate form. So let's apply L'Hopital's rule.
It's time.
So the limit as x approaches, what are you doing? Oh. Limit as x approaches pi over 2. Let's see. 1 plus secant of x.
It would be...
Well, oh yeah, the derivative of
derivative
secant of x is secant tan
It is.
We just said this.
Oh, yeah, we did.
over the derivative of tangent is secant squared.
Oh, we're killing it.
Which means you can get rid of the secant, right?
Yeah.
Yay.
Okay, so I'm just going to rewrite this so we see what we had, okay? Limit as x approaches pi over 2, tan x over secant x. Wait, what? This actually didn't help us at all. I mean, it did, but it didn't. Because as we approach pi over 2, tangent goes to infinity. As we approach pi over 2, tangent goes to infinity.
Oh.
As we approach pi over 2, secant goes over. Okay. Well, let's see.
So is this just like infinitely?
Being awful.
Is it just like infinitely indeterminate? It's infinitely infinite.
Well, what if I try to rewrite this? So tangent is
Infinity.
That's like a fourth wall break.
sine over cosine.
It's like 16.
And if I'm dividing by 1 over cosine, it's the same thing as multiplying by 1 over cosine. I don't think this is actually going to help me. Secant is 1 over cosine. So I'm dividing by 1 over cosine. Oh, wait. I'm going to be multiplying by cosine over 1. Cosine over 1. So which means these go away. Do you see what I did there? The same thing as saying the limit of x as it approaches pi over 2 of sine of x. Do you know how I did this?
Yeah.
No, you don't. I see him. Sine over cosine is the same thing as tangent. Okay. Secant is the same thing as saying 1 over cosine. Instead of dividing by 1 over cosine, instead of dividing by 1 over cosine, multiply by the reciprocal, cosine over 1. Same thing as sine of x. Cool. What is the value as x approaches pi over 2? You know sine of pi over 2 is just 1. Dunzos.
Nice word.
Thanks. It's like
It's like you know.
it's like I know it, yeah.
Like I probably wouldn't have to do that. That's what you were supposed to do.
Well,
Although
I'm
maybe.
like, wait, I could put this in sine and cosine. This is from pre-cal. This is what I do with my pre-cal kids. I was like, air 5. Unless it's like really good, then I'll walk over and give them a real 5. The first time I did that was a guy who just got back from being sick for a week and think that through, and he was really sick. I didn't think it through. Touch a man's hand. That was germy. All right, let's keep going. You wrote that down. All right, now let's try this. Limit as x approaches infinity of ln of x over 2 times square root of ln
Hi,
of.
Daniel, just checking in. You're doing okay. Hope you did well at your Berkeley audition.
Indeed.
Miss you.
Did he go to Boston?
I don't think so.
Oh.
Did you go to Boston?
Oh, shut up. Boston's a beautiful city. I hope he gets in.
Yeah, me too.
I will literally, I will come and visit him just so I could go to Boston.
If you become a Red Sox fan, then I'll eat you.
Oh, Daniel will get on my gay. All right.
Daniel what?
On my gay. Red Sox.
You said automatic game.
That's what I heard.
A plus. Okay. All right, let's do this. So, if I put in infinity, what is the value of ln of infinity?
I would imagine.
What's the value of 2 times the square root of infinity?
It's probably something.
Check it out. We identified the indeterminate form.
Yes.
Stellar job. Wicked.
We got a high five for that.
Wait, shit, no.
Yeah.
Okay, cool. So, the derivative of an ln is
1 over x, right? Right?
I always get confused on which it is. Like,
Yes.
with, like integrals and derivatives. Like, what is what?
So,
I think it's 1 over x.
I just know that we don't know the integral for ln.
So then, yeah.
So it's 1 over x. Nice.
yep, the derivative of ln of x is just 1 over x. Over, this is a rough one. All right, so 2 square root x.
As long as you x.
So 2 to the x to the 1/2.
So let's see, that's 2 times 1/2 times x to the negative 1/2.
Oh, because it's like a constant, so it goes out in front.
Yeah, because the 2 is in front, and then the whole like square root thing is just x to the 1/2. So when I take the derivative of x to the 1/2, it's going to be 1/2 times x to the negative. Okay, so this is just going to be 1 over, well, I'm going to, root x. Yeah, root x. Okay, 1 over root x. Oh my god, can I rewrite this? Can I just like go to the right, rewrite this? Okay. So instead of dividing by 1 over root x, I can multiply by root x over 1. Did you hear what I just said? No, you didn't. What did I say?
That you're going to put it in x.
No, that's not what I said.
I apologize.
Okay.
Okay.
1 over 8, 1 over x, I'm dividing by 1 over root x.
So that's
So what I can do is 1 over x multiplied by root x over 1. So I'm just going to rewrite this little limit here. Just make it look a little nicer, a little cleaner. So root x over x. Cool, right? So as I take the limit, as you know, I approach infinity, what happens? What's square root of shoot, we're still infinity over infinity. Dang it. Okay, so now let's take another derivative. What's the derivative of the bottom?
1.
1, right? Okay, cool. So what's the derivative of the top? What's this go to?
It'd be 1 over 2 to the square root of x. 1 over 2 to the square root of x.
1 over 2 square root x?
1 over 2 root x.
Yeah.
Okay, and as this approaches infinity?
Still 1 over 50. Well, it's 1 over 50, so that's not indeterminate.
Which goes to, right, 1 over infinity.
No, it goes to 1.
1 over infinity?
Wait.
When the bottom gets really big.
I just gotta think about it.
It goes to 0.
Yep.
Oh, yeah, right.
Goes to 0. Cool, done with this one.
Wait. That's it?
Yeah.
Oh.
See, let's try to let's keep going. All right, see, limit as x approaches infinity of x times sine of 1 over x.
All genders, all cool genders in here.
All right, Louis, lead us through this one. First, I need to identify the indeterminate form.
So it's infinity sine of 1 over infinity, which is
It's infinity
0 sine of 0. Wait, 0.
Infinity
No, but it's times 0.
times 0.
So it's just 0.
That's the indeterminate form.
That's an indeterminate form. That's not 0 over 0. Oh, how about that?
Sometimes handle the indeterminate forms infinity times 0 by trying to get 0 over 0 or infinity over infinity instead.
Wait, isn't infinity minus infinity like 0?
No, because it could be anything.
It could be bigger than infinity.
Yeah.
Yep.
Ooh.
So,
Yep.
out of curiosity, what is infinity plus 1?
I'm not having this discussion with you right now.
Why?
And I'm not getting into philosophy.
It's important.
You know what's important? Getting through these notes so you don't bomb a test. Okay.
Yeah, but another one.
That was not directed at anyone. I'm just saying, please focus, please. Okay. Okay. So limit as x approaches infinity, 1 over, okay, we did this. So what we need to do is take the derivative, let's see, limit of x as it approaches infinity. So I want to make it into indeterminate form.
Okay, so
So what I'm going to do is rewrite this as, up above, it said, we can sometimes handle the indeterminate forms by using algebra to get 0 over 0 or infinity over infinity instead. So if I do, okay, x is the same thing as saying dividing by 1 over x, right?
I guess.
do you mind if I just text my group? Because I don't know if we're supposed to leave early.
That's fine. So saying x over 1 multiplied by x over 1 is the same thing as dividing by 1 over x.
Yeah.
Multiplying by a reciprocal, same thing as dividing by, okay. Okay, so I'm not changing this at all, I'm just using a little algebra. So I have sine of 1 over x divided by 1 over x. That's the same thing as saying x times sine over 1 over x. Okay, this time when I plug in infinity, I'll get 0 over 0, which is indeterminate. Awesome, that's kind of what I want. I want it to be in an indeterminate form, so I can like apply L'Hopital. Because sometimes, yeah,
No,
see how I got algebra?
I just don't know how you did sine of 1 over x.
Multiplying by x over 1, same thing as dividing by 1 over x.
Where are you multiplying by x?
Right here. Yeah, fucking ant. Stupid ants. All right. Yeah, that's
You're
right.
so clever with your algebra.
Thanks.
Math is cool.
All right, let's keep going. So, okay. So I didn't apply L'Hopital's yet, right? All I did was like algae. All right, but I see I have indeterminate. Yeah, algebra. So now I can apply some of that L'Hopital because now I have indeterminate 0 over 0. So let's see, limit as x approaches infinity of, okay, so let's do the top first. So sine of 1 over x, the derivative of that.
So real quick, I don't know if I'm supposed to leave early, but we haven't set up any of our stuff, and as soon as we're done with this, we have to go to like this big like town hall thing that I think we have to be at. So I don't know if I'm supposed to go set up. Can I go like 5 minutes early?
Yeah. What time is this class in?
Like 5 minutes.
Okay.
Yeah, because I need to finish my task and then we'll begin.
Oh yeah.
Let me just finish this one real fast since we're in the middle of it.
Do you need my calculator?
Derivative of sine of 1 over x is going to be cosine 1 over x. Multiply by, well, this is the chain rule. So I did the derivative of the outside, multiply by the derivative of the inside. Derivative of the inside is just going to be negative 1 over x squared. So that's for the top. And then, wait, on the bottom, what's the derivative of 1 over x? 1 over negative 1 over x squared. So you notice how this guy actually like cancels out. Awesome. So I'm going to take the limit. So is equal to limit as x approaches infinity of cosine of 1 over x. Well, 1 over x approaches 0 as x approaches infinity. So cosine of 0 is just going to be 0. See ya. This is all I want to do. See, that's all it took to finish this one.
Wow, it was so cool.
Yep. Yeah, it's going to take 0 period to finish the rest of 8.2. And then we'll take the regular period.
Class till Tuesday?
Right, we don't have classes on.
Wow.
Yeah. So we'll take 0 period, finish 8.2. Take the regular D period on Tuesday. Do the practice quiz and do a little reviewing. And then Wednesday is your quiz.
So we are on track.
Yeah, I mean, I originally had put 2 days for this. I just, like getting ahead.
Yeah.
Because then it's less stressful. Because I'm like, oh, okay, cool. If we run into something we don't know, we're fine. And then Wednesday is your partner quiz. That's when all your homework's due.
When you say partner quiz, there's only 3 of us. You just mean one.
I mean, the 3 of you are working together, more or less. All right, cool.